So good afternoon, everybody. This is lecture 15 of our machine learning course, Python for machine learning. And today we will review the last lecture regarding NumPy library. Then we will continue our exploration of NumPy using additional notebooks. So as I mentioned in the last class, NumPy is a scientific computing library, especially useful for manipulating large arrays, large matrices, maybe multi-dimensional arrays or matrices you can manipulate with NumPy. So NumPy has certain properties, it is implemented as a class, the NumPy class has certain properties which are very useful for manipulating large quantities of complex data. So let us straight away go to today's Jupyter notebook and see what is there in store for this lecture. Okay. So this is hope you are able to see this. Okay. So first of all, we will review last lecture. The last lecture I mentioned about NumPy. NumPy, as I already mentioned, is a scientific computing library, especially targeted to its computation, manipulating large arrays. So in order to import the NumPy class, what you will do is this, like we will import NumPy as NP. So this is any name you can give, but in general people tend to give NP because it's a short form of a NumPy. And once you have this class imported to your code, you can create NumPy arrays. So NumPy arrays is created using the array method. So within brackets you will give the row of the array. Oro row list. You can even use tuples here. You can even use list. You can specify either as a list or a tuple. So this is what we did in the first last lecture. So if you print it, you will the A is an object created using this particular method, array create method. So A is an NPy NumPy array. If you print the type of this, it will say it will maybe type of. So let's see, what is it? Shoe. So this is shown as NumPy ND array. So this is n-dimensional array. But even now we have only one dimension or one row, but later on we will build bigger things. So this is the comparison between NumPy and Python. Python objects. So Python also has some kind of these capabilities. So it can represent integers, floating pointers, contain lists and dictionaries. Whereas the NumPy is an extension to provide multi-dimensional array. It's closer to hardware. I can say that it has been efficiently implemented, and you may get higher speeds if you use the array compared to Python lists or so. So this is designed for, and maybe it is something called array-oriented computer. See, and NumPy extensively manipulates arrays. So we saw different data types. Oh, there's an error. Okay, again there's an error. Okay, when I typed it, it came like that. So NumPy provides different data types: integers, floats, complex, booleans, strings, etc. So we have seen in the last class. So let us quickly review it. So I am creating an array here, 1, 2, 3, 1, 2, and let's see what is the type of that. So I am printing the data type, a.data type. So a is an object here, an instance of this particular object, and it has this method data type. It will print its own data type. So what kind of array it is. So by default, this, when you say that, it's an integer 64. So it's a 64-bit integer. So instead, if you say a point here, see, this is the above thing and this line are similar, except that I have a specific 1 point, 2 point, 3 point, etc. So but let's see what happens when you run it. Okay, let's try print B also. So B also I'm printing. So yeah, so this has now a complex data type. So this is treated as 64-bit floating point number. So the type, if we just specify a point here, it will take a 64-bit floating point number. So by default, say integers of NT array are 64-bit integers, and floating points are 64-bit floating points. So that is what you infer from this. So you can even do. So that is not needed here. See, so let's see this one. C is another array. C is another array that I have created, but with the float type. So even though this is 1, 2, 3, I have specifically said while creation. So within this bracket, after the list, I say that the data type will be float, so that this will be treated as floating point things. This is or with the point things. So you can even say complex things. This also we saw. So J is the imaginary number or square root of -1 in NumPy. Or NumPy provides certain constants like pi, e, etc. So you can have Boolean arrays. Boolean array. So this is a Boolean array. I have demonstrated a Boolean array. The data type is Boolean. So you can even have strings. See, an array of strings. You see, you can say array of strings. Let's see what happens if we store a set of arrays and find out the data type. Its data type is, now it is saying that data type is U. So they are all Unicode strings. This says that Unicode strings less than maximum length of 7. That is the meaning of this. So you can even create NumPy array with strings also element. So this is what we saw in the last class. Now we looked at certain array creation functions. Array creation functions like linspace and log space, linspace, runtime, and all. So this is another one. So let's see. Let us run this linearly. See, I created a linear spaced elements. An array linearly spaced elements are created. And here, I think I mentioned about this also. So this one, A. Now, as a random string. So between, see, 4 numbers of random integers it is creating. So all of them, if you are in doubt, you can refer to the documentation. See, our NumPy library has an extensive documentation which you can refer to. So even at any point, if you are in doubt, you just read the doc. Now we will move on to 2D arrays or higher dimensional arrays. So essentially, the purpose of our ND array or NumPy array is to create bigger dimensional matrices or arrays. So let us see. This also, I think I briefly mentioned how to create a 3D bigger dimension array. So this one creates this such kind of an array. You see the results as well as the functions that I have written. So B is an object of type the NP array, np.array. So the first row I have specified as a list. comma, the second list is second row. Now, if you run it, so you will get this like this. So let us find out the shape of this. If you want to see the shape of the object, it will say it is a 2 rows and 3 columns. So dimension ndim will print you the number of rows, number of dimensions. You can transpose this one using a dot t operator. So you can transport an array and transpose this 2D array using dot t operator. Dot t will print. And then we saw about arithmetic operators. They apply element wise. Element wise, you can add and multiply, subtract, etc. And if you want to do the normal matrix multiplication, that is row into column kind of operation, that is called a dot product. So that is our most important product also. As far as an array, matrix is row vectors are concerned, you have the opportunity for taking dot products. So we will see how all these such things are taken now. So I'm creating two arrays. You see, A is this one. A is this array, and B is a second array. Both are 2 by 2. Both are 2 by 2 square matrices. So let us print both. So let us run this one first. Run A and let us print A. So A is 1101. So it is exactly run, and B is 2034. Now let us see how we do element-wise multiplication. Element-wise multiplication means A0 will be multiplied by B0, and this way this is multiplied. So this is the element-wise multiplication. So let us see and let us see how this looks like. So seems to be correct because this is 1, this is 1, and this is 2. So 1 into 2 will be 2. The result is 2. Now where is this? Oh yeah, it looks fine. Now let us again look at this. The actual matrix multiplication or dot product, that is, you multiply by a row by a column. This kind of operation is being done using the at symbol. So let me I have A here, so let me print it again. A is here, B is here. Now, if you run that multiplication, so this is the exactly what you should expect when you take a dot product. Now again we saw some so I think this much we had seen the last class. Now we will explore new things. The first thing we will explore today is some additional functions for creation of multidimensional arrays. So we need most of the time we need certain special kinds of arrays while manipulating big matrices. So for example, if you want an array of zeros, so you can do there's a special method np.zeros to 10. So that means that will give an array of 10 zeros. So that is what is shown there. You can see this. So let us run this again. See, an element of np.0 create an element with this one. Okay, we can even create say 10 maybe 10, 10. Say what we'll see. I think it can give you an error. Okay, there's because that index you should give as a tuple here. If you are indexing additional things, this should be given as a tuple. Okay. Yeah. So we have created a big array. Somebody came and left. Okay. So this way, and what will happen if you give one more? So let's explore. See, I created a huge matrix 10 by 10 by 10. everything containing 0. See the results it printed. So while doing such things, so you can even bigger. So this is a 3D. This is a 3D matrix. So each dimension it has 10 zeros. 10 zeros, 10 x, y, z, all the 3 axes you have 10 zeros. So this way you can create bigger matrices, bigger in the sense n-dimensional matrices. You can, if you give one more dimension, say let us for convenience, let us say 2 here. So this is a 10 into 10 into 10 into 2. So you have so many things. See, you should explore. You should actually run this and see how this comes up, how that each individual element comes up. This way, you can create bigger and huge matrices. So similarly, you can create a matrix with or an ND array with all ones. NP ones will provide you a mechanism for creating a matrix with all ones. So this is what is done. You can, this is creating 2 by 3 array of all ones. Okay, let me run it. So that created this. No, maybe, okay. No, let us, you can create even more, like say 3. So that will create a matrix like this. So it is kind of, you can think of it as 2 slices, say 1, 2 in this way. Say first slice is first that what is written first, and the second slice is this one. So it's a 3D array. In one dimension, it has it has only 2 elements, and the other 2 dimension it has 3 elements. Okay. Now, sometimes you may need a constant array in which everything is a constant. Like you can say that you can do it like this. See here, I have created something of C with NP full. This will create a matrix with of this size with this particular constant. So this will create a matrix 3 by 2 matrix, 3 by 2 matrix with everything filled as 7. So okay, let's see. അപ്പോൾ ഈ സാധനങ്ങളെല്ലാം നിങ്ങളെ ഞാനിങ്ങനെ ഡെമോൺസ്ട്രേറ്റ് ചെയ്ത് കാണിക്കുന്നത് ഇതെല്ലാം നിങ്ങൾ മെഷീൻ ലേണിംഗ് അൽഗോരിതംസ് ഉപയോഗിക്കുമ്പോൾ നിങ്ങൾക്ക് പലതരം ഓപ്പറേഷൻസിന് വേണ്ടിയിട്ട്, ഉദാഹരണത്തിന് നിങ്ങൾ ഫിൽട്ടറുകൾ അപ്ലൈ ചെയ്യുക, നിങ്ങൾ ആംപ്ലിഫൈ ചെയ്യുക, ഒരു സിഗ്നലിനെ ഇത് ചെയ്യുക, അങ്ങനത്തെ പർപ്പസിനൊക്കെ ഇത്തരം മെട്രിക്സുകൾ ആവശ്യമുണ്ട്. അല്ലെങ്കിൽ നമ്മൾ പലപ്പോഴും അങ്ങനത്തെ ഓപ്പറേഷൻസ്, ഇപ്പോൾ ഒരു ഐഗൻ വാല്യൂസ് എടുക്കുക, ഐഗൻ വെക്ടേഴ്സ് എടുക്കുക, അങ്ങനത്തെ സാധനങ്ങളൊക്കെ ചെയ്യുമ്പോൾ probably you need all these kinds of matrices. That is why I am introducing you to all these functions. So this it will become more clear when you learn the math behind this, as well as when you do that actual machine learning algorithm later in your course. Okay. Now this is another one. Another one is an identity matrix. Identity matrix is a matrix in which only the diagonal elements are 1. So you can do eyes. Eyes is the one. Okay, somebody came late. I np.I. So this is an identity matrix. This is the thing for an identity matrix. It will create this way. 3 by 3 identity matrix. If you put 4, it will create a 4 by 4. 4. And you can even think of say 4 by 3 here. So this will be a bigger, or yeah, what happened? Something wrong. Okay, let's see it. You can have the other dimensions also, and that I. And if you want to create a random number array, so this is also sometimes needed, especially when you do signal processing kind of jobs. You need random noise, you need random things. So random can be created using, there's a np.random library. NP has a random library, and you can create a random numbers. So there are other methods also for creation of random numbers. Okay. Now you can an empty thing. So I say leave it. I forgot what was that. Empty. So you can look up that empty thing. Okay. Now let us come to the most important things. Thing of the array operations in our ND array operation. That is accessing array elements. Accessing array elements. So, ഞാൻ ഇത്രയും പറഞ്ഞത് നിങ്ങൾക്ക് മനസ്സിലാക്കേണ്ട ഒരു കാര്യം, നമുക്ക് ഈ ND array അല്ലെങ്കിൽ ഈ numpy array വെച്ചിട്ട് നിങ്ങൾക്ക് ഏത് ഡയമെൻഷനിലുള്ള ഹയർ ഡയമെൻഷനിലുള്ള അറേകളുണ്ട്, മെട്രിക്സുകൾ ഉണ്ടാക്കാം. അപ്പൊ നമ്മൾ സാധാരണ നിങ്ങളുടെ മാത്തമാറ്റിക്സ് ക്ലാസ്സിലെല്ലാം 2 അല്ലെങ്കിൽ 2 ഡയമെൻഷനുള്ള മെട്രിക്സുകളാണ് ചെയ്യുന്നത്, എക്സ് വൈ. മേ ബി in your 3D geometry you have seen 3x3 things or 3-dimensional things also. So they are represented as 3 numbers. അല്ലെങ്കിൽ നമ്മുടെ ഒരു 3x3 മെട്രിക്സ് എന്ന് പറഞ്ഞാൽ you can think of it as points on a space. അല്ലെങ്കിൽ 2x2 മെട്രിക്സിനെ നമുക്ക് നമ്മുടെ പ്ലെയിനിലുള്ള 2 പോയിന്റുകളായിട്ട് എടുക്കാം. അപ്പൊ നമുക്ക് നിങ്ങളുടെ മെഷീൻ ലേണിംഗ് അൽഗോരിതംസ് എല്ലാം തന്നെ ഹയർ ഡയമെൻഷണൽ സ്പേസുകളിലാണ് വർക്ക് ചെയ്യുക. അപ്പൊ നമുക്ക് സിംഗിൾ ഡയമെൻഷൻ ഇസ് എ ലൈൻ, മേ ബി ഇറ്റ്സ് എ ലൈൻ, 2 dimensions are is a plane, 3 dimensions is a space. So you have 4 dimensions, 5 dimensions, higher dimensions are possible, but those are abstract things. നമുക്ക് അത് വിഷ്വലൈസ് ചെയ്യാൻ പറ്റുകയുള്ളൂ. They are represented using these matrices. അപ്പൊ അങ്ങനെ ആ മെട്രിക്സുകളെ റെപ്രസെന്റ് ചെയ്യുന്നതിന് വേണ്ടിയിട്ടുള്ള വഴിയാണ് ഈ NDRA കൊണ്ട് ഉപയോഗിക്കുക. അപ്പൊ ഇനി നമുക്ക് കാണേണ്ടത്, ഇങ്ങനെ ക്രിയേറ്റ് ചെയ്ത NDRAയിൽ വലിയ ഹയർ ഡയമെൻഷൻ അറേയിൽ ഇൻഡിവിജ്വൽ എലമെന്റ്സിനെ മാനിപ്പുലേറ്റ് ചെയ്യണം. മെട്രിക്സിന് ഒരു ഇൻഡിവിജ്വൽ പർട്ടിക്കുലർ എലമെന്റിനെ എടുക്കുക, അല്ലെങ്കിൽ ഒരു സ്ലൈസ് എടുക്കുക, അല്ലെങ്കിൽ ഒരു പർട്ടിക്കുലർ റേഞ്ച് മുതൽ ഇന്ന റേഞ്ച് വരെയുള്ള സാധനങ്ങൾ അതിൽ നിന്ന് എക്സ്ട്രാക്ട് ചെയ്തിട്ട് ഇത്തരം ഓപ്പറേഷൻസ് നമുക്ക്, ഇത്തരം പ്രോഗ്രാമുകൾ നമുക്ക് നിങ്ങളുടെ റിയൽ ലൈഫിൽ പല സ്ഥലത്തും ആവശ്യമുണ്ട്. അപ്പൊ അതിനുള്ള വഴിയാണ് ഇനി നമ്മൾ കാണാൻ പോകുന്നത്. അപ്പൊ നമ്മൾ ആദ്യം തന്നെ നിങ്ങൾ മനസ്സിലാക്കേണ്ടത്, ഇതിന്റെ ഇൻഡെക്സിങ് 0 മുതൽ n-1. ഇപ്പൊ n എലമെന്റ്സ് ഉള്ള ഒരു അറയില് എന്റെ ഇൻഡെക്സിങ് തുടങ്ങുന്നത് 0 എന്നാണ് തുടങ്ങുന്നത്. 0 to n-1 വരെ ആയിരിക്കും ഇൻഡെക്സുകൾ ചെയ്യുക. അപ്പൊ ഇത് നമ്മൾ ലിസ്റ്റിന്റെ കേസിൽ ഇത് കണ്ടിട്ടുണ്ട്. ലിസ്റ്റ് എലമെന്റ്സ് ആക്സസ് ചെയ്ത് എങ്ങനെയായിരുന്നു? 0 എന്ന് പറഞ്ഞാൽ ആദ്യത്തെ എലമെന്റ് കിട്ടുക, n-1 ആയിരിക്കും nth എലമെന്റ്. അപ്പൊ അതേപോലെ തന്നെ ആണ് നമ്മുടെ ഈ array NP array case. So let us create an array. A എന്ന് പറഞ്ഞൊരു അറേ ഉണ്ടാക്കി. അപ്പോൾ അത് 10 എലമെന്റ് ഉള്ള ഒരു അറേയാണ്. 0 മുതൽ 9 വരെയുള്ള എലമെന്റ് ഉള്ള അറേയാണ്. So let us insert a few cells here. Let me insert cells below. Okay, couple more. So A is A0. So let's see what is A0. A0 will be your 0th element. A1 will be the second element. This element 1. Now A10, let's try A10, because it's an index error, because this is an array with just 10 elements. So the maximum you can go up to is 9. So individual elements of a single dimensional array can be accessed this way. Now if you had a 2D array, so let us copy a 2D array from here. So we had created some 2D array here earlier. So the distinct array. Okay, yeah, here. So let us take this one. So better take this one because this is having different numbers. Okay, copy. So let us create one here. Okay, let us call it as a B. So our B is this kind of an array. Now, okay, let's print B. Now, okay, insert one more cell below. So B within 1, comma 1. Let's see what this gives. What happened? Okay. Yeah, I made a mistake here. Accessing is within this one. Square, we should access using square brackets. So I made a mistake. Yeah. So this is, let us look at it. B is like this, 0, 1. 0 is this element. This is 1. So 1, 1 will be this 4. First row, first column. Or second row, second column. So because your indexing start from 1. I mean 0. So this is how you adjust things like this. So similarly, you can. So in the case of lists, we were able to access from the right or negative indexes you could use. So let us look at A again. Yeah. So let us for negative indexes. Let us insert one more here. So let us print of A. Let us run A. A is like this. So -2, A -2 will be what? So this is taken from -1. This is -2. So up to -10 will be possible. So let's see whether -10 is there. Yeah, -10 will be 0. So in one direction, 0 to 9, and the other direction, you got a -1, -2, -10. So you can do a negative indexing. So let us do something. So you can. Next we come to the idea of slicing. So our A right now, the array A right now is this. Now suppose you want to take say from 2 to 5, or this much you want to take. This much of this array, you want to take it and copy it and assign to another array. So for that, you can use slicing. So a slice of this array can be done like this. So now you come here, look here. B is, I am going to take A 2 to 5. 2. So have a look at it. 2 will be 0, 1, 2. This is 2. 2, 3, 4. So when you slice, this is a starting point. This is an ending point. Start, stop, start, stop. There is one more thing. I will come to that. So it will slice from start, but end -1, stop -1. But this is what you get when you slice a thing. And of course, you can have a one more. I think maybe 2. Okay, let us up to 9 with a step of 2. 2 ഇടപെട്ട് നമുക്ക് എടുക്കാൻ പറ്റും. 2 അത് കഴിഞ്ഞിട്ട് 2 പ്ലസ് ഇത് സ്റ്റെപ്പ് 2, 4, 6, 8 അതായത് സ്റ്റെപ്പ് ഇട്ടിട്ട് ചെയ്യാൻ പറ്റും. ഇഫ് യു ഇൻക്രീസ് ദ സ്റ്റെപ്പ് ടു 3, യു വിൽ ഗെറ്റ് എ ഡിഫറെന്റ് സ്ലൈസ്. അപ്പൊ നിങ്ങൾക്ക് ഈ രീതിയിൽ 2, 3, 2, 5 അങ്ങനെ നിങ്ങൾക്ക് സ്ലൈസ് എടുക്കാൻ പറ്റും. അപ്പൊ ദിസ് ഇസ് പോസിബിൾ ഓൺ ഓൾ ഡയമെൻഷൻസ്. ഞാനിപ്പോ ഇത് ഒരു ഡയമെൻഷനിലാണ് കാണിച്ചെങ്കിൽ നിങ്ങൾക്ക് മൾട്ടി ഡയമെൻഷണൽ അറേയിലെ മൾട്ടി ഡയമെൻഷൻസിൽ പോസിബിൾ ആണ്. 2 മുതൽ 5 വരെയും ഒരു ഡയമെൻഷനിലും മറ്റേ ഡയമെൻഷനിൽ 4 മുതൽ 6 വരെ. അപ്പൊ നിങ്ങൾക്ക് വലിയ ഒരു 3D മെട്രിക്സിനകത്ത് ഏത് പോർഷൻ വേണമെങ്കിലും ഈ രീതിയിൽ കട്ട് ചെയ്തെടുക്കാൻ പറ്റും. ഏത് പോർഷൻ വേണമെങ്കിലും കട്ട് ചെയ്ത് നിങ്ങൾക്ക് വേറെ മെട്രിക്സസ് ഉണ്ടാക്കാൻ പറ്റും. That is the idea of a slicing. We will do some more exercises on slicing. Now, when you take a slice and modify that slice, you have to be very careful, because your slice is not a copy. So ഞാനിപ്പോ ഇവിടെ മുൻപത്തെ എക്സാമ്പിളിൽ ഞാൻ പറഞ്ഞ തെറ്റിയിരുന്നു. നമ്മൾ ചെയ്തെന്ന് വെച്ചാൽ എ എന്ന് പറയുന്ന മെട്രിക്സിൽ നിന്ന് ഒരു സ്ലൈസ് എടുത്തു, ബി അതിലെ എയും ബിയും ഒരേ ഡേറ്റ തന്നെയായിരിക്കും റെഫർ ചെയ്യുക. അതായത് ഇത് രണ്ട് വ്യൂസ് ആണ്. നിങ്ങൾക്ക് അണ്ടർലൈൻ വലിയൊരു മെട്രിക്സ് ഉണ്ട്, അതിനകത്തുനിന്ന് എ എന്ന് പറഞ്ഞ ഒരു വ്യൂ ഉണ്ട്, ബി എന്ന് പറഞ്ഞാൽ അതിന്റെ ഒരു സ്ലൈസിന്റെ വ്യൂ ആണ്. അപ്പൊ നിങ്ങൾ ബി എ മാറ്റിയാൽ ഒറിജിനൽ എ മാറിപ്പോകും. ഉദാഹരണത്തിന് let us have a look at the same example here. നമ്മുടെ എ, so let us insert a couple of more cells here. Okay, one more. So let us look at A. A is right now 1 0 1 2 9. Now let me take a slice. Copy. Let me copy this and insert one more cell here. Yeah, I am taking a slice. This is B is right now a slice to let's take it 7. So this is slice. So let us print B. B is right now 2 3 4 5 up to 6. Now even though A and B look different, they are actually same. The underlying data is same. So I will show you that. Now you are going to change B0. B0 is this one, 2. In the place of 2, we are going to add N99. We are going to assign a B. So now and then let us print A as well as B. Let's print B first. So we are going to modify B. But the original B here, move it. Now let us, if we print A, if you print A, so let us print A. A also has changed indirectly. But see, be careful about this. B ഒരു സ്ലൈസ് എടുത്ത് വേറെ അറയിലേക്ക് അസൈൻ ചെയ്തിട്ട് നമ്മൾ സ്ലൈസിൽ ചേഞ്ച് ചെയ്താൽ ഒറിജിനൽ അറയിൽ ഇത് റിഫ്ലക്ട് ആവും. Now that is what is you are seeing here. The original array has been modified. So be careful while writing code. So this slicing is actually this slice is actually a view of the original data. And so if you want to copy instead of a view, or you can use a copy method. So definitely you can copy a dot copy. So it will take a copy of A, and then you can change this one. If you want to take a copy, you should use the copy method. So see this. Now I have A remains same. A has no change because even we have taken a copy of C of A and manipulated this. Okay, let's see. Let's print C also here. Yeah. Only one is printed. You need to, if you want to print both A and A, you have to execute some command which I had mentioned very early in your course. Now I have to remember and to find out that command and execute it first. So it is an option of Jupyter. So multiple line additional. Now next let us look at some other array manipulation commands. The first thing is we will see is reshape, a command called reshape. Now if you look at the code here in this line, so let us look at up to this part. Say here I'm commenting remaining of this. So let us see what is A. A is 25 element array 0 to 25. So I have created using arrange function. Now you can, once you have created this, you can reshape this created array into something else. So I have created this into a 5 by 5 matrix. You see, by using the dot reshape 5.5. So this object, see, this is the beauty of object oriented programming also. So what I have done is I have created an object with this much size. That is what is this instance. Then I reshaped itself to something else. So with another command. So let us run it again. So what happened? So it has been reshaped into 5 by 5. So took the first 5, then second 5, third 5. This way, if you look at the shape, maybe you can shape of A, insert cell below, dot shape. If you run dot shape, run dot shape, you'll see a 5 by 5 earlier. So actually what we created originally was a single dimension array. We reshaped into a 5 by 5 array. Now you can access individual elements this way, individual slices or things like that, you this way. So now you have 2, 3 means so this is 0, 1, 2, 3, 0, 1, 2, 3. That will be 30. So that is what we are getting, A, 2, 3. So if you omit, so for a multi-dimensional array, if you omit one dimension, say here I have only one dimension. So that will print the entire row here, entire row. So 15, 16, 17 എന്നുള്ളത് മൂന്നാമത്തെ 0, 1, 2, 3, the fourth row. The entire row can be accessed by not specifying the column. So a column you can extract this way. You put a column in the first place. Third column, if you want to access third column of this, that is this 3, 8, 5, 13, 18 അല്ലേ, അത് നമുക്ക് access ചെയ്യണമെങ്കിൽ okay, what you should do, you put a colon, comma, 3. This will print, this will take you the vertically, it will give you vertical slice of this one. Now you can do something like this. One colon. So our A, let us print our A again, A, so that you can see. So A looks like this. A, 1 colon comma. So this means ഒന്നാമത്തേത് മുതൽ in the dimension of 1, 0, 1. 1 is this. ഇത് മുതൽ താഴോട്ടുള്ള എല്ലാം എന്നാണ് 1 comma colon എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ മീൻ ചെയ്യാം. See, so this for particular 1 colon എന്ന് പറഞ്ഞാൽ ആദ്യത്തെ എലമെന്റ് സ്പെസിഫൈ ചെയ്യുന്ന ഒന്നാമത്തെ കോളം മുതൽ 0, 1. So let us ഫസ്റ്റ് കോളം മുതൽ ഫസ്റ്റ് റോ മുതൽ താഴേക്കുള്ള എല്ലാ റോസും എടുക്കുക. Then ഇനി അതിൽ നിന്ന് അടുത്ത സ്ലൈസ് എടുക്കേണ്ടത് എന്താണ്? അതിനകത്തെ സെക്കൻഡ് കോളം 0, 1, 2 സെക്കൻഡ് കോളം 0, 1, 2 കോളം മുതൽ അതിന്റെ താഴെ റൈറ്റിലേക്കുള്ള കംപ്ലീറ്റ് സാധനങ്ങളും എടുക്കുക. So that is what this means, second 2 colon. So essentially what you get is you get this slice, this much. I cannot mark it there. You can directly correlate with these two matrices. ഇങ്ങനെ നിങ്ങൾക്ക് സ്ലൈസ് എടുക്കാം. Exercises for I will upload this to Moodle. We're using slicing, so different kinds of slice here, this way, that way, etc. If a slice dimension is not specified, it is taken as 1. Okay. You can actually different kinds of shapes you can try. Yeah, see, I am giving some more exercises here. You can actually the ideas are clear or straight away. You can try out the slicing mechanism, different slicing things I have given. Different ways in which you can take all these slices. Okay, now I think I will wind up at this point. So